same sheet, but 13 to 25. I can make it a little bit smaller. Okay, so let me read this. David's earnings, okay. So we have 4 questions here to answer. Question 1 says, based on the graph, is the relationship between x and y proportional? Explain your reason. Well, it's definitely proportional, if you can see. Goes through the origin, it's a straight line, and if you want further proof, you can do k over y, k equals y over x, and you can take all these points, point 90 and 3, so let's just do that. If you take 90 and 3, you would get 30, right? $30. That's our constant proportionality. If you took this point right here, which is, and I'll write it over here, 2 and 60, you notice that constant proportionality would also be 30. If you took this point over here, it would be 30 over 1, and that's, by the way, our unit rate, and I'll just write unit rate right away. 30 over 1, which equals 30. So our constant proportionality is the same for no matter what point you use. So there you go, and goes through the origin. 2, what's the point 390 represent in the context of the situation? The context situation, it says that in 3 hours he earned $90. That's what the point represents. Based on the graph, how many dollars will Mr. David earn if he worked 10 hours? So now, once I have the constant proportionality, right, you come up with an equation? The equation would be y equals kx, or y equals 30x. Yeah. X represents the number of hours, and y represents how much he earns. So if he works 10 hours, it would be y equals 30 times 10, and y equals $300. So he would earn $300 in 10 hours. Writing equation that could be used, well, I already wrote the equation. Y equals 30x is our equation. So one leads to the other. Okay. 14. Can we make this a little bigger? All right, so you have a calculator, but you just got to be careful because they're telling you to subtract this first. So it's a negative minus a negative, or a negative plus positive. It really is up to you how you see it. So I'm going to do that in a calculator. So it's going to be negative 1/5 plus, right? Because a negative and a negative becomes plus 2/3. And unfortunately, I can't change this to decimals, and that's going to give us 7 over 15. So we get 7 over 15, and then we're going to multiply this by a negative. Can we simplify anything? Yeah, we can do the 5 and 15, so that becomes 1. This becomes 3. Final answer, negative 7 over 18. Okay. A student had 500 milliliters of water in a water bottle. She drank 25% of the water before the soccer practice. After practice, she drank 1/3 of the remaining water. How much water in milliliters does the student have left in the bottle? All right, so let's draw this. So right now, she has 500 milliliters. So if she drinks 25%, 10, 20, 25, that means she still has 75% of whatever water she had. So, and we can find out how much water she has left. 500 times 0.75. 500 times 0.75 equals 375. So she has right now 375 milliliters of water. After practice, she drank 1/3 of the remaining water. Okay, so if you take 370, so let me draw this, and let's just focus on the tops. 3 has 375, and let's break this into thirds. If you take, she drinks that much away, how much is left over? So, if she drinks 1/3 away, right, you're still left with 2/3. So, how much is 2/3 of 375? So, we can get 2/3 times 375. So, what's 2/3 of 375? That represents how much she has left over. Those times 375, and that means she has 250 milliliters of water 17, one evening the temperature decreased by 5 the first hour after sunset, and then decreased by 7 each hour for the next 7 hours. So wherever the temperature was, it decreased by 5, so minus 5. And then it decreased 2 hours each hour for the next 7 hours. 7 hours, so it was -2, another -2, and -2. So we went down another -14 in total after 7 hours. Okay. The temperature then increased by 14.5 the next morning, and then it increased by 11 that afternoon. What was the total change in temperature? So -5, -14, and then it went up by 14.5, and then it was up by 11. So what was the total change in temperature? Let's see. -19 plus 14.5 plus 11, 6.5. And we end up, the temperature increased by, so a total of 6. So if you think about it, it decreased -5, decreased -14, and it goes up 14.5. We'll take it about here. And then it goes up to 11. We don't know where it lands or where it ends up. Doesn't matter, but whatever it was after all these changes, basically the temperature went up by 6.5 at the end. Consider the expression absolute value of 4 is 4, plus the absolute value -7, which is 7, and that's 11. 18. The manager company wants a survey. So this comes to statistics. We will sort of tackle this, hopefully. Wants to survey a representative sample of the company's employees to choose a company logo. Which of the following is a representative sample of the company's employees? So you want to survey, and you want to survey everybody. Not everybody, but people in the accounting department, some people in the engineering department, some people in the cleaning department, some people in the security department. So you want to make sure you get a little bit of everybody, right? And you get everyone's opinion, everybody that sort of represents each of the groups that belong to the company. So how should we sample? How should we come about to do that? All right, so let's say your company is a big company. Will be a fair way of doing this. So every third company from the largest department in the company. So if you get every third employee from, let's say the engineering department, okay, and then the accounting department, let's say those two, and then you have several departments. Let's call this the cleaning department, the security department, what else? The IT department. So let's say this is the smaller groups, and these are the main ones, right? So if I select every third person from this department and every third person on this department only, would that be a fair representation of the company? Obviously not. Every employee who enters the employee cafeteria. You're going to survey every employee who enters the employee cafeteria? Do you think that's a fair sample? What about those people that don't eat the employee at the cafeteria? So how do you know people from the engineering department go there, and the accounting department, the cleaning department, the security department, and the IT department? Do they all go there? We don't know. So just to survey those people, I don't think would be the right way. Every third every third employee on the company's payroll. Whew, that seems about fair, right? So you look at the company's payroll, everybody who gets paid by the company, and you get every third employee. That seems like random, right? And fair. Every employee who's under the age 35. No, that doesn't even make sense, right? So because you're excluding everybody above 35, which again, it doesn't represent the whole company. So C, out of all these, seems like the best choice. 19. What is 19? Nia, Colton, and Ian use the same taxi company to travel. Okay. The initial fee for a taxi ride is $260. So that means that just for you hopping on the car, on the taxi, you gotta pay $260. You're just by you open the door, sat on the cab, he turns the meter on, you already have to pay him $260, and you haven't even driven anywhere. Okay, just little help for the guy, you know what I mean, to make sure he earns a little bit of guaranteed money every time there's a customer in the taxi, and then plus each mile that travels, he gets an additional $2.50. So plus $2.50 per mile times the number of miles. So that would be your total. That's how you calculate how much you have to pay at the end of your ride. So one day Mia rode 2 miles in a taxi. What was the total cost? Well, $2.60, the initial fee, plus $2.50 times 2. So it's $2.60. $2.50 plus 2 is 5. So she ends up paying a total of $7.60. That would be A. B. Colton rode in a taxi to get to work. The cost of his taxi was $9.60. Let's actually represent the number of miles Colton rode in the taxi. Which of the following equations represent this situation? So we already have the equation. So if the initial fee plus the miles times 250, all that equaled 960, how many miles did he travel? So this would be the equation that we would use. And is there anything that looks like this? 250x plus 2, well, there we go, right here. Okay, the cost per mile plus the fee equals $9.60, which was his cost. So how many miles did he ride for? So number 1 would have been your correct answer. C, based on your answer to part B, what is the total distance in miles? So we actually have to solve it. So we're going to go minus 260, and this is going to give me 7, and 250m. Divide both sides by 250, and 7 minus 2.5 equals 4.5. So the number of miles that he rode for was 4.5. Ian rode a taxi to get to the airport. The total cost of the taxi was more than $12. Write and solve an inequality to find the possible distances. So again, same inequality, but so 2.6 was the initial fee plus 2.50 per mile was greater than 12. So what are the possible distances that he could have traveled? Well, minus 2.6, 250m has to be greater than 9.4, divided by 2.50 or 2.5. Oh, battery. And m equals the number of miles that he has to ride so that it equals greater than 12. 9.4 minus 2.5. The number of miles have to be greater than 6.9. As long as he travels more than 6.9 miles, his cost is going to be greater than 12. Good question. Don't know if that was probably a part 2, right? Day 2. That question. This one, tree diagrams, and we'll do some of this next week, I think. The teacher has a number cube with number faces 1 through 6. So 2 dice, right? 2 regular dice. He's going to roll the 2 cubes. So think about what happens. If you roll the number 1, the first one. So let me call this the first roll. And this is the second roll. So a tree diagram shows all the possible outcomes. So if you roll a 1 on the first one, what can you roll on the second one? You can roll a 1, a 2, a 3, a 4, a 5, and 6. So you can get a 1 and a 1, a 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6, right? What if you roll a 2 on the first one? Well, then the second one, you can get a 1, a 2, 3, 4, 5, 6. So you can get a 2 and a 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6, etc. So these are all the possible things. There are 36 different. 36 different. So if I list them, I can get a 1 and a 1, 1 and 2, 1 and a 3, 1 and 4, 1 and 5, and 1 and 6. Second time around, I can get, or I can get a 2 and a 1, 2 and a 2, 2 and a 3, 2 and 4, 2 and 5, 2 and 6. So how many different possibilities can happen when I roll when I roll 2 dice? I can have 30 different possible outcomes. So 36 different outcomes, right? So out of those, how many will give me the sum of 8? Well, if I roll a 1, I can't get an 8 no matter what I roll on the second die. If I roll a 2, what can I roll on the second die to give me a weight? Well, I can get a 2 and 6. So 2 and 6 will give me 8, right? 2 and 5 will not, 2 and 4 will not, so 2 and 6 is the only one. If I roll a 3 on the first die, can any combination give me an 8? Well, if I throw a 5 on the second one, I'll get an 8. So 3 of 5 is another one. 4, if I roll a 4 on the first die, and the second die I must roll a 4. That'll give me 8. 5, well, 5 and 3. 5 on the first, 3 on the second. And then 6, if I roll a 6 on the first one, I need to roll a 2 on the second one. So, out of all these 36 possible outcomes, how many will give me the sum of 8? 5 different combinations. So, what's the probability of you throwing 2 dice and getting the sum of 8? Well, you have a 5 out of 36 chance of that happening. Circle has a radius of 6. Okay, which of the following is circumference of the circumference? There's 2 ways of finding the circumference. I just like to use this one. If you want to use this one, that's okay with me. So this one says circumference equals pi times diameter. And this one says circumference equals 2 times the radius times pi, which is the same thing. Isn't twice the radius the same thing as diameter? So in this circle, I'm just going to add the diameter. So if the radius is 6, I know the diameter is 12. I'll put radius over here. But it's up to you which one you want to use. That doesn't really matter. C equals pi times the diameter. I'm going to use diameter, which is 12. And they actually want you to multiply that. So in your calculator, go 12 times pi, enter, and do that. And press this button over here. And you're going to get 37 point, what are we rounding this to? Well, it seems like they rounded to nearest tenth, so we're going to round 37.7. There. If you use the bottom one, C equals 2 times pi times the radius. 2 times 6 is 12. And then you multiply that pi, and you'll get exactly the same thing we got over here. So it doesn't really matter which one you want to use. 20, that was 22, which means I skipped 21. Okay, so 21, the expression, we have something, a television. Television right now. 0%, 100%. The price is P dollars. If you take 20% off, you're still responsible to pay for 80%. So this is what you pay. So P equals 1/5 of P. So P minus, sorry, what does it say? P minus 1/5 of P, that's okay. Which of the following is another expression that can be used to find the sale price of television? So when you and I did this, we're going to use P times what are we paying for 0, 80%. So this is the other expression right here. Okay. Now what are they doing here? So here they're actually finding the discount. Okay, they're finding the discount. They're finding the 20%. Okay. 1/5, by the way, is the same thing as 20%. Agreed? So they're finding the discount, and once they find the discount, they're subtracting from the original. So they're finding the discount, and then they're subtracting it from the original to find final price. That's what they're doing. Okay, that's what they're doing here. But we want the more direct way. I don't know. Not too many people do it this way. 22. Oh, wow, 22. Oh, so this had a, what's the area? So the circle question had a second part. So we want the area. So again, area equals pi r squared. And if you look at the answers, they're all left in terms of pi, so we don't actually have to multiply. So we have the radius, which is 6, so a equals pi times 6 squared. A equals pi times 36, or better yet, a equals 36 pi square meters, and the only one that looks like that is 3. (23) distributive property. We get negative 4x plus 4 plus 2. Combine these two guys, we get negative 4x plus 6. We cannot combine like terms, so this is our final answer. And then we have our last question. Customer wants to purchase a sweater from the store. The original price is $40. Okay. The sweater is on sale for 10%. Then another coupon for 25%. The customer claims that she can determine the price of the sweater by taking 35% off the original price, since 10 plus 25 plus 35. Which of the following is true? Can you actually do that? Can you, if you had two coupons, can you add them together? Would that give you the same price? Well, let's find out. So the customer claim is correct. The final price of the sweater will be $5. What? I don't think so. Customer claim is correct. The final price of the sweater will be 26. Customer claim is incorrect. The final price of the sweater will be 27. The customer claim is incorrect. Well, let's see what happens. So if you take we do it the way we did it. After first discount, we have to pay for 90% of the sweater, correct? And then after second discount, we would have to pay for 75% of the new value. So 40 times 0.9 times 0.75. That's going to take us to $27. So that's the price that she would be paying. Now, the only one that mentions 27 is this guy here, which is saying that she's incorrect. Well, let's see if she's incorrect. She's actually doing this. She's saying that I can add 10 plus the two discounts together, 10, 25. I get 35%. Right, so let me try it. So 0, 100. So what she's saying is that here's the price of the sweater. So instead of taking 10% off, and then multiplying by 40, and then multiplying by a discount of 25%, which is represented by what you're left with to pay. She's saying that let me add the 10% plus the 25, and that's 35%. So I'm left with 65% of the value to pay. So this is what she has to pay. Well, let's see if we get the same answer. If you take 35% off, you're left with 65%. And 40 times 0.65 equals $26. Now, notice there's a little difference here. This, her, is incorrect. You can't add that. So therefore, C, our original, is the only right answer. Okay, so, and I'm going to do this using the bar model just one more time. So think about this. You have your sweater, which is $40. And let's go for your 10% discount. Take 10% away, you're left with 90%. Right? So $40 times 0.90. After 10% discount, you would have to pay for $36. So your sweater is now $36. That's your first discount. Your second discount, from $36, you have to take 25% off. So again, let's draw the bar model. Ignore the first one that you drew, so that's no longer relevant. Now 100% of your sweater is worth $36. And we're going to take 25%. 10, 20, 25. So now, on the 36%, $36, you're responsible for 75%. So 36 times 0.75. That would give you what you would have to pay, which is 27. Okay, so notice that her 26 doesn't really work. And I think that's that.